Graphical games and correlated equilibria. Our second case study is an examination of graphical games and correlated equilibrium. As has already been noted, if we are fortunate enough to be able to accurately represent a multiplayer game we are interested in as a graphical game with a small degree, the representation benefits purely in terms of parameter reduction may be significant. But this is still a rather cosmetic kind of parsimony. We shall see a much deeper variety in the context of a correlated equilibrium. The first issue that arises in this investigation is the problem of representing correlated equilibria. Recall that NE may be viewed as a special case of CE in which the distribution P of a error is a product distribution. Thus, however computationally difficult it may be to find an NE, at least the object itself can be succinctly represented. It is simply a mixed strategy profile, P arrow, whose length equals the number of players N. Despite their aforementioned advantages in moving to CE, we open a representational Pandora's box. Since even in very simple graphical games, there may be correlated equilibria of essentially arbitrary complexity. For example, the CE of a game always include all mixture distributions of NE, so any game with an exponential number of NE can yield extremely complex CE. Such games can be easily constructed with very simple graphs. More generally, whereas by definition, in an NE all players are independent in a CE, there may be arbitrary high-order correlations. In order to maintain the succinctness of graphical games, some way of addressing this distributional complexity is required. For this, we turn to another older graph-theoretical formalism, namely undirected graphical models for probabilistic inference, also known as Markov networks. Lauritsen, 1996. We will establish a natural and powerful relationship between a graphical game and a certain associated Markov network. Like the graphical game, the associated Markov network is a graph over the players, while the interactions between vertices in the graphical game are entirely strategic and given by local payoff matrices. The interactions in the associated Markov network are entirely probabilistic and given by local potential functions. The graph of the associated Markov network retains the parsimony of the graphical game. We will show that the associated Markov network is sufficient for representing any correlated equilibria of the graphical game up to expected payoff equivalence. In other words, the fact that a multiplayer game can be succinctly represented by a graph implies that its entire space of CE outcomes can be represented graphically with a comparable succinctness. This result establishes a natural relationship between graphical games and modern probabilistic modeling. We will also briefly discuss the computational benefits of this relationship.